So our speakers tonight have flown in especially to talk to us, and they are going to talk about the Los Angeles Metro project tunneling, past, present and future. So our first speaker, who's speaking first?
We're doing a bit of a double act.
All right, so Matthew Crow, Deputy Executive Officer, Los Angeles Metropolitan Transportation Authority. For the last decade at LA Metro, Matthew has been involved with development and implementation of underground rail transit projects, including planning, engineering and project management. Recently, he was Deputy Project Manager for Section 3 of the Purple Line extension. Matthew started his tunnelling career in the UK with Howard Humphreys under Martin Knights and Maurice Gooderham, working on the planning, design and construction of projects for natural gas, sewers, highways, electricity cables and rail transit. Notable projects being the River Tees Tunnel, Millennium Cable Tunnel and Cromer Outfall Tunnel. At the British Tunnelling Society 25 years ago, he explained the pre-vaulting technique used on the Ramsgate Road Tunnel. He moved to the USA with Brown and Root, performing construction management of stormwater and sewer tunnels, including the ECIS Mega Sewer Tunnel in Los Angeles and the Waller Creek Stormwater Tunnel in Austin, Texas. He is active in the profession, serving on the Executive Committee of the Underground Construction Association and the Advisory Board to the Dean of Engineering at Cal State University, Los Angeles.
Do you want to do Amanda as well?
Yeah, we'll do Amanda as well. Okay.
We don't want to interrupt.
You were getting ready to speak, though, that was all. But yeah, Amanda Elioff's background is in planning, design, development and delivery for light and heavy rail subway systems. She has served as Deputy Project Director, Project Manager and Engineering Manager for multiple phases of Los Angeles Metro system development. Her responsibilities have included conducting geotechnical investigations and feasibility studies, developing specifications, preparation of geotechnical baseline reports, and providing design support for construction. Amanda's design and construction experience also includes water and wastewater tunnels and an underground physics research facility. She has worked on design criteria for underground structures and design testing of mitigation measures for construction in gassy underground conditions. Currently, she is WSP's manager for Section 1 of the Purple Line Extension project under construction in Los Angeles, and engineering manager for San Francisco Bay Area's Link 21 planning and engineering team, studying a second bay tunnel crossing and major regional transportation. Amanda has been active in professional associations, American Society of Civil Engineers, past president, director, American Underground Construction Association, and VP, International Tunneling Association. Recently, she was a member of the committee preparing the ASCE publication, Geotechnical Baseline Reports. This manual of practice explains the role of GBRs in allocating and managing risks associated with subsurface construction. Amanda holds MS and BS degrees from the University of Texas, Austin. Okay, Matthew.
Okay, let's get cracking. We're going to talk about LA Metro, past, present and future, a bit about the geology, go back to the 80s with the red line, to the noughties with the gold line, and then the 2010s, 2010 or whatever, 2010, 2020 with Regional Connector, Crenshaw and Purple Line, which are recent and current projects. A little bit of chit-chat about future projects, so you can put it down to a bit of BD tonight. And then some of the advancements and things that we've learned from our 40-year program. Los Angeles County, it's a big area, over 10 million people, and it's growing. It's famous for its freeway system and also busy city streets. Wilshire Boulevard is one of the busiest in the United States. And if I drove to work, that would be my commute there on the right. Looking at, this is a people's whole profession, isn't it? So I'm going to do it in 2 minutes or minute, the geography and geology of the area. If you look to the, oh God, is that the right one? Here we go. Laser, here we go. So here we've got the Santa Monica Mountains. So and then we've got the San Fernando Valley up north. Then we've got the west side and the city of Los Angeles. We have earthquakes, oil fields, there's lots of gassy tunneling. The other thing, we've got the LA River that does some stuff. So, geology. Okay, I was going to say basically, Peter Townsend. But I did. Anyway, so we got a whole mix of stuff. We've got obviously the rock in the mountain. At the bottom, we've got this Fernando Formation, which is a siltstone, claystone. I guess it's a bit like a good London clay. But above that, we have sand, silt, gravel, clay, cobbles, boulders. And it's the kind of thing, imagine the mountains being eroded and the river depositing them and then cutting through it. So it's a bit mixed up, okay? And above and below the groundwater table. LA actually has quite a big history of tunneling over the last 150 years for railroad. Here we go, railroad, transit. Where are we? There. Freeways, highways, and water and sewers. So it's not a new thing to us. Also, Los Angeles, the reason why it's so spread out is not the freeways. Actually, it actually had, again, you can see the mountains and then the west side and then the San Fernando Valley. But you can see that the red and the blue lines are railroads, either the streetcar type thing, or actually this is a 4-track electric commuter rail. And it originated from the horse-drawn tram with a particularly lazy horse there. And as with all good things, when the system had been completely abandoned, there were no tracks left, we kind of thought about how to put them back again, back in the 60s. And, I can't think. Amanda's going to talk about some sensible stuff now.
Right. So hello, everybody. Thank you for coming. It's good to see some old friends here and from ITA and such. Anyway, so Matthew and I are kind of doing a little bit of a tag team here, and hopefully we'll manage to do that well. But so I will start out with a past project, which is the Los Angeles Metro Red Line. I lost the screen. I'll see if they can get it back on. But the Red Line is the first heavy rail tunnel built in Metro. First tunnel heavy rail metro from downtown Los Angeles out to the San Fernando Valley. And it was instigated by Mayor Bradley in the 1970s.
Don't ask me about IT, Amanda.
Started by Mayor Bradley in the 1970s. If anybody flies into Los Angeles, they fly into the Bradley terminal. He was a promoter of transit. But there is actually a long history of planning for the metro systems. There are a lot of stops and starts for funding. They finally came up with a new approach where the state created the Los Angeles County Transportation Commission to sort of coordinate all of the municipal operators and have more efficient funding. So in 1980, the voters of Los Angeles actually voted for a half-cent sales tax to help fund transit projects. And a locally preferred alternative emerged from downtown Los Angeles along Wilshire Boulevard up Fairfax and out through the Santa Monica Mountains to the San Fernando Valley and actually connect these population centers. There's no screen here.
All right, yeah. Do you know about this, Gabor? There's no screen.
So I'll keep going though while they repair that. But this alignment was not really to be in that form due to the presence of gases underground. Yeah. There are many oil fields in Southern California. Actually, at the turn of the 20th century, it was one of the major oil producing cities in the world. And there's one particular area along Wilshire Boulevard that's very famous called the La Brea Tar Pits. And in this area, oil actually seeps out of the ground. We like this little sketch because it was done by a man named Byronish Canyon who actually developed those. No?
Is this one Byron?
Yeah, same one. Who was the author of the tunnel safety orders. Anyway, in this tar pit area, mammals from the ice ages would come, they were attracted to the tar thinking it was water, get in there, get stuck, and actually perish. And so there are many, many prehistoric ice age fossils that are being recovered from these tar pits. There's actually a museum that's a famous attraction. You could go see the fossil remains. But because of a non-metro related incident in 1985, the alignment had to be realigned around this tar pit area. The incident was a methane explosion under a department store slab. Nobody was killed, but it was quite sensational. And as a result of that, the city of Los Angeles created a methane zone, which you can see, here's the explosion area, the tar pit area, and the alignment had to be rerouted around that methane zone. And the United States Congress actually voted legislation to not fund any metros in that zone. So, not going on Wilshire Boulevard in 1986. The original methane zone was about 1.5 miles by 1 mile square. Sorry about the American units, but at least you guys have heard of it. The new, or the present methane zone covers much of the city. The purple circles are the methane zone. The yellow is what they call the methane buffer zone, and there are different requirements for construction and investigation in those zones. And for instance, the building code requires that buildings in the methane zone have to have additional geotechnical investigation, barrier systems for basements, permanent gas monitoring systems, and subterranean ventilation. And these photos are actually from the building I work in near the job site. So Metro Red Line construction began in the 1980s. It was mostly cut and cover stations, braced excavations, soldier piles and lagging, dewatering depending on the groundwater conditions at the station locations. They used wood decking over the open cuts. This was not popular with drivers. Sometimes the decking was raised to reduce utility relocations. So that was later replaced with precast concrete panels. Tunnel construction used open shields, except through the Santa Monica Mountains where there were hard rock TBMs used. It's a photo of the rock machines. These were named Thelma and Louise to give you an idea of the time frame of this tunneling. And the ground support, initial ground support was rock bolts and sometimes steel ribs. And the final lining was cast in place concrete. So we mentioned that methane in the ground, so we had a design for mitigating methane. The red line design included a two-pass system, which was an initial precast concrete segment, expanded lining, no bolts, followed by a high-density polyethylene liner. That's called HDPE, and that's used because it's methane resistant. A lot of testing was done to confirm that, and followed by a cast-in-place concrete lining. So we're basically sealing the tunnel. For tunnel construction in Gassing Ground, I was happy to see Donald Lamont here too tonight, follows these California safety orders that we mentioned. These safety orders require that methane has to be diluted to less than 5% of the lower explosive limit. There has to be continuous monitoring during tunneling, and equipment has to be approved by MSHA. And this is the Mine Safety Health Administration, a federal agency. And the equipment must be certified to be intrinsically safe or non-sparking. It should go without saying that there's no smoking allowed in the tunnel. You'd be surprised. But also no cameras, no cell phones, unless they have special covers. The main ventilation systems have to exhaust gas and be made of rigid metal. And most of the time we have to maintain a probe hole ahead of the tunnel face unless a variance can be obtained from Cal OSHA. So during operations, some similar mitigation approaches, mentioned the HDPE barriers. We also have continuous monitoring for methane and hydrogen sulphide gases in the tunnel. There's alarm levels for certain percentage of the lower explosive limit, and then fans are activated if they detect, I think it's 10 parts per million. And then at a higher level, the tunnels have to be evacuated. Normal ventilation from the train push and pull really keeps gas at any small amounts of gas diluted to acceptable levels. And of course, there's emergency fans if there are fires or higher gas levels. HDPE is also used for the station barrier systems, and welds have to be tested extensively to make sure there are no breaches in the lining. And so spark testing or vacuum testing is used on those welds. There were a few incidents reported during the red line, so you can see this is the same sketch. But generally speaking, things went well. In this case, there was actually some tar that leaked through those initial precast segments in a section of the tunnel that was just west of downtown Los Angeles. Other challenges from geology include earthquakes. Metro developed a two-level design approach for seismic design, an operating design earthquake, which has a 50% chance of occurring in 100 years. And the structure must be designed to have no damage and be able to go back into immediate operation after a brief inspection. And then there's a maximum design earthquake, which is a larger earthquake or more ground deformation, lower probability of occurrence though. And in this case, structure must be designed to maintain life safety, but may be repaired. And also in operation, there are seismographs in many of the stations, and the state of California has an early warning system, and either of those will detect ground shaking or acceleration, and trains are stopped. Soft ground also posed some challenges for the open face shield tunneling. And most of the time things were just fine. However, there was some surface settlement due to ground loss, and this led to some media attention. The picture on the right is the Walk of Fame on Hollywood Boulevard, and some of the famous terrazzo sidewalks with the stars in it settled, and people complained about that. And about the same time as the Heathrow sinkhole, there was one along Hollywood Boulevard. This was not due to shield-driven tunneling. It was actually occurred during remining of a tunnel that went offline. I meant to mention too on the sinkholes that I think Shani Wallace is here. Matthew reminded me that she had some good articles in the archives if anybody wants to follow up on those. One other notable experience was a tunnel fire. This was early on in the Red Line construction under the 101 freeway there. East of downtown, it's a tunnel that actually went to the yard leads. Wood lagging was used, it caught on fire. This freeway was closed for a little while. So now no wood lagging is allowed in the tunnels, but fortunately the chief engineer, Jim Monsees, had specified permeation grouting under that freeway, so the freeway did not collapse and went back into service shortly and after a few days. So because of the public perception of construction issues in Los Angeles, like, is it okay to tunnel there? The Metro created a tunnel advisory panel. And the members of this panel, some of you may know or have known Harvey Parker and Dan Eisenstein. They were ITA presidents, and their charge was to study tunnels worldwide and compare the experience in Los Angeles to those. And not surprisingly, they concluded it's not too different from anywhere else at that time, but they did recommend that pressure-faced TBMs be used in the future. So Red Line was completed in about the year 2000. Technology advances were recognized. The design criteria for seismic design, gas barriers, gas mitigation, and subway operates safely. Just a few pictures of the completed stations. This is the artwork. So represents the diversity of Los Angeles County and the local industry, the film industry. Each station has a different theme. But despite the Tunnel Advisory Panel's findings, subway construction was stopped in 1997. And the voters actually went the other way and said, no, we don't want to spend any more sales tax on subways. Some politicians had just been to Brazil and they decided that busways were the way to go. So the East Side Heavy Rail project that was planned was put on the shelf, but it actually reemerged as a light rail line to East Los Angeles. And we were able to use the TAP recommendations for pressure-faced machines. And the success of this East Side project was really critical to get the tunneling moving again on the west side. So this Gold Line project on the east side was also through through an old oil field. It only had 6 kilometers of tunnel and 2 underground stations. But the TBM specifications were written for either slurry or EPB machine to operate in the geologic conditions there in gassy ground, made sure we had tail shield grouting and all the stuff we talked about back then. But it could be used with a single pass liner. And I should point out that Matthew Crow gave me a copy of the draft BTS specifications back then, so we were actually able to take advantage of those. Thank you. Precast concrete segmental tunnel linings were about a 5.7 meter diameter, single pass, but they had to be designed with sort of the same concept as a redundant system with 2 types of barriers. So they were designed with a double gasket and a convex to convex radial joint. So they'd actually rock during a seismic event and the gasket would always be sealed. I saw Mike King somewhere. He did the final design for these segments. The segments were, before final design, we had an extensive testing program of this joint system at the University of Illinois and tested for leakage after the compression and flexure tests. And we have a picture of the double gaskets at the tunnel heading. The TBMs selected by the contractor were a bit unique. They were 200-foot, had 200-foot or 60-meter screw conveyors. And the idea here, and I think this was something that the contractor, who was Trailer Brothers, had worked out with Martin Heron Connect. So the muck and gas, if there's gas, is discharged well away from the heading, and additional ventilation can be supplied at the screw discharge. A couple of pictures of folks at the Heron Connect plant and the screw discharge area. So because of the success of this project, there was actually 0 settlement, according to Dan Eisenstein, which is in the less than ½ an inch or 10 millimeter level. We didn't have to use some of the compensation grouting that was planned, and it wasn't activated. Some pictures of the hole through and the finished tunnel. And again, success of this project is what allowed us to go forward and eventually get the congressional ban on tunneling lifted. It wasn't just the lack of settlement, it was also the contractor's safety record, a happy community, and the input of special APTA panel that I'll talk about when we get to the red line. And this kind of swayed voters back the other way. And not only, they were probably tired of sitting in traffic as well, but in November 2008, they voted a half-cent sales tax again for transportation upgrades for 30 years. And then in 2016, another half-cent sales tax to extend the sales tax from 2008. But this alone wasn't enough to fund the subway. It also gets federal funding and other local funds. So I will turn this over to Matthew.
Okay. Thanks, Amanda. So let's talk about some more recent projects. What are we talking about? 2010s and 2020s. Regional connector, Crenshaw, and then the Purple Line extension, which is the jewel in the crown of Metro. Crenshaw LX, it's a light rail thing. So that light rail, what do we mean by that? It's a bit like the British Rail, Merseyrail trains, except they're able to do street running, and it's got overhead power. So actually more like Newcastle Metro. So it's got, who cares about that? It's got 3 underground stations with twin bore tunnels connecting them. So that's, and it's over in this part of, there's the airport there, the sea. And this is the Crenshaw district. It's famous. That's where Meghan Markle comes from, whoever she is. Okay, bit about support of excavation. Again, braced, we did braced, but it's like standard to all of our system. And braced excavations with steel pipe struts and steel soldier piles, top-down construction, concrete road decking, and the shoring was. We'll talk a bit about that later. And one of the things that's really important is we have very prescriptive Metro Rail design criteria and standard drawings for shorings that we make sure our designers follow and our constructors implement. And when we do that, we don't have any mishaps. It's very, very, very important to us. One of the two of the stations were built using to build the walls. We use the cutter saw mixed wall. Some of you might not be aware of this system. So essentially, what it is a rotating cutter head here, cutting in a big trench here, filled with bentonite, cuts it all up. And then instead of the soil being removed we displace the bentonite with cement, and it mixes to produce a soilcrete. And before it sets, we push in these soldier piles to the surface so that we've got the steel piles. And then that's the finished product. You see the steel soldier piles, and that face is just cut with the back of an excavator bucket. And that's, you can see it there, if you're bored. The reason why I mention this is we actually had a academic, so it's not just Matthew Crowe like picking the numbers he likes to show off. They actually did some proper research. And they compared the two systems, where we have the conventional soldier piles and the timber lagging, wall deflection 25 millimetres and surface assessment about half that. Not too shabby, you know. When we use the cutter sill mixed walls, we have a wall deflection of about half, and then we had, you think all the same, we actually had heave. And the reason for that is because the wall was so stiff, there isn't much wall deflection, but when you dig a great big hole in the ground, you get this elastic relief, and then the ground next door comes up. So that was an interesting thing that we discovered. The other thing we did is, Amanda mentioned the HDPE waterproofing system. That's the only material we can use, and it's very difficult. But we improved the system by compartmentalisation in 10 square foot compartments with this water bar here. There's a regrouseable Foucault hose around each compartment, so we can re-establish it if the compartment leaks. And then you have, at each compartment, you have 4 grout ports. And the reason we do this is not only able to fix anything during construction, which we did on Crenshaw to make a beautiful, dry station for our operations folks, but it also enables, any midlife, refresh, Something we're very proud of here, Ed Cording, Dr. Ed Cording, had the Muirwood paper, the ITA, on this subject. He's very proud of this, and so am I. So I won't say it's my idea. But it was a new innovation to Metro, so that's how I look at it. So it's got the pressurised face, again the pressurised grouting Amanda talked about, but also putting in pressurised bentonite in the shield around the tunnel as we go along. So that's what we do. And there's another picture of a TBM. Those of you, that's the late Paul McNally. Anyone who knew him, electrician from Dublin. And if you don't, well, you know who he is now. We used, again, double gasketed segment, but the enhancement we did here on Crenshaw was we put a cross gasket on the seat joint. These segments designed by John Hurt of Arup. That's what he actually does some work in the States. Great engineer. So note that location. And the reason we put the cross gasket in is so that we compartmentalise the tunnel in 1.5 metre lengths, so we can do future grouting in the gap between the two segments in a meaningful way if we have future leakage or something happens, so that we've got a tunnel that will last for kind of ever. You know? Regional connector, another light rail project. It's downtown Los Angeles, 2 miles of tunnel. Connects, we have 4 light rail lines that weren't connected. This connects them all up. It's got 3 underground stations. Super project. You should, it's great. But we're not that interested in the project. We're interested in the tunneling, of course. So the first part of the tunnel has about 1.5 diameters overburden here, and it's in slop above below the groundwater table, so quite tricky tunnelling. And there happens to be a very culturally sensitive building above, so we mandated the installation of compensation grouting tubes, and doing that compensation grouting enables the tunnel underneath this complex of buildings with nominal ground movements. Another interesting feature was with crossovers typically cut and cover structures, but here we have the Los Angeles Police Department building, the Higgins building, and just here that's where Sir Colin Barrett, one of our great engineers, happens to live. Not only the tall buildings, but they also have basements that extend over into the street. There's also a large diameter storm drain. And, but thankfully, instead of being this alluvial material, we have the Fernando Formation, which is the siltstone, claystone. So it enabled us to, for Derek Penrice of Mott's, there's his, that's what he does, he does these pretty coloured cartoons. And, okay, it's not like the crossover tunnel on the Channel Tunnel, but it's, to us, it's very special, you know. So we've got this lovely cavern with sequential excavation. We're careful of the naming. We don't call it Natum or anything. And it's, what is it? 90 metres, 80 long, 18 metres wide, and so it's pretty impressive. But you can't see it. It's all filled with ventilation and stuff when it's now. Other thing we have, back in the 80s, they built all these high-rise buildings. You saw on the first slide. They had 3 to 4 stories of underground basements built with soldier piles and used tiebacks into the street. You can tunnel through a few, but not a forest of them. So where we had knew these were, we found a place to sink a shaft where there were no utilities, and sunk a shaft, liner plate and ribs, and then sequential excavation. Found the tiebacks, cut them out, filled it with artificial soil, and bada bum, tunnel through it without mishap. Sustainability. Someone said, got to talk sustainability. So, here it is. Gold line TBM. There's Amanda. There you go. And these are the 2 TBMs there. Okay. What do we do? No. Here we go. Same TBM, but it's had a bit of makeup there, as you can see, up in Seattle. And then the TBMs for regional connector. It's not only it's had a bit of a face work and a nose job there for regional connector. So that's kind of interesting. Yeah, you're supposed to say, yeah, it's interesting. What about the projects? These are real projects, very useful, and they enable, you can get Azusa, it's like 25 miles from downtown, goes through downtown actually goes down to Long Beach, it's a big city, it's on the beach there, and then from East LA, that's the Amanda project talked about, through downtown to Santa Monica Pier, which is all rather nice, and you're all connected. Purple line, so I'm going to hand over to Amanda again. So.
Okay, I'm back. All right, so the Purple Line project is one that's actually in construction today. It is being built in 3 sections, 1, 2, and 3, very original. And it goes from the end of the existing, it's now the Purple Line here, existing line out to the UCLA, that's the University of California, Los Angeles, and the Veterans Administration Hospital, and there are a lot of Olympic venues. Los Angeles will host the Olympics in 2028, so I'm sure some of you understand the pressure of getting things finished before the Olympics. The project also goes through a number of jurisdictions, the City of Los Angeles, City of Beverly Hills, federal land, and some state property. So there's a lot of coordination to do with third parties as well. Planning began in 2007 and projected to finish construction of Section 3 in 2027. So just a few highlights from this project will be, how did we lift those funding restrictions that were on Wilshire Boulevard? A little bit about how the tunneling went and the gassy ground around the tar pit area. We had some oil wells that needed to be located and abandoned before tunneling. Some of the changes and advancements from the existing red line, and Matthew will talk a little bit about construction successes. So how were the funding restrictions lifted? Basically through more information, the success of the gold line proved tunneling could be done, and other improvements in technology. Besides its pressure-phase TBMs, we had looked at some gas extraction methods to reduce gas in the ground during tunneling, and better monitoring of the environment. And also, we had another panel called into action that was called the APTA panel, which is the American Association of Public Transportation Officials, and they will help supply you peer reviewers for whatever type of problem that you have. So this panel was called in 2005, and they concluded, based on all the data they had, that it would be safe to tunnel in the methane zone area. However, only slurry TBMs would be allowed because they could contain all the gas in the tunnel and it gets released at the surface. And we should maintain the 2-pass lining system. So based on that, the United States Congress reversed the legislation. But we had then a follow-up panel in 2012 after a lot more geotech exploration had been done. And the panel said, yes, EPBs can be used, especially considering that there was a lot of siltstone in some of the tunnel reaches, which would be difficult to process. And that if we could develop a 1-pass liner system that had the ability to add a second liner in the future, then that would be acceptable. So some of the additional investigation included increasing the boring spacing to less than 100 meters, continuous core borings, and this panel also recommended that we do a large exploratory shaft. Here's just some pictures of the tar-infused soil. Here's a split spoon sampler of tar sand, and it could actually smell it when you're drilling and opening those samples. Some other pictures of the tar, which is a continuous maintenance problem in the city because it actually comes up through the pavement and the city is always maintaining it so it doesn't get on people's cars and cause other problems. There's again the picture of the tar pit museum. The city actually has sumps in some locations that they have to come vacuum out every month or so. So the exploratory shaft was considered very successful. It was a 7 by 12 meter box 23 meters deep, and it was constructed with soldier piles and a shotcrete lagging. And from the shaft, we could obtain large block samples to test for soil properties, observe ventilation requirements, refine methods for recovering fossils, because those were expected throughout this area wherever there was tar, and develop protocols for working with the paleontologists. And at one time, the bidders could come and look at the shaft before they prepared their proposals for construction contracts. So paleontology had to be considered in the contract documents. The GBR had a paleo layer, and it was in that paleo layer, excavation could only occur within 6-inch or 15-centimeter lifts to avoid disturbance of fossils. So that did slow things down, but that was to be included in contractor's bid. There was a paleontologist on site at all times during investigation to keep an eye out for anything interesting. And we did find numerous Ice Age fossils and coordinated those findings with the county museum. The final geologic profile for the Purple Line had all of our friends, Old Alluvium, Young Alluvium, Lakewood, San Pedro, and a bit of siltstone on the east side. And here it's kind of interesting, in the Wilshire-Fairfax area, this red line represents the top of the asphalt impregnated soil in that Wilshire-Fairfax area. So TBM was remarkably similar to the TBMs used for the Gold Line regional connector. It was a new TBM though. There were actually two in each section for construction. And the tunnel lining was also a one pass with this provision for a second lining. And one of the improvements was the double gasketed system with cross gaskets. A little bit different though from the Crenshaw one. I'll show you some pictures. The contract also required additional soil conditioning for asphalt to infused soil. And some of the initial tests we did were actually at the University of Torino, so we shipped soil over to Italy for testing. And it actually wasn't too problematic. Just a few pictures of TBMs coming through the station. You can actually see them here. And I also wanted to highlight, this picture shows our station arch. One of the things that changed from the Purple Line was that we removed the columns from the stations and had a slightly narrower station with an arched roof. So the single pass linings here were the same size as the Gold Line, but the heavy rail system has about a foot diameter difference from a light rail line, so came out to the same size. And here you can see that the cross gasket for the Purple Line is actually on the circumferential joint. And Matthew has now codified the location of the gasket in the Metro criteria. And I mentioned the tunnel was sized to add the second liner. If in the future there was leakage of gas or water, you can add a second liner, not easily, with because you have the space for it. Tunneling went very well. Average settlement was less than allowable. Some of this tunneling was in some pretty sensitive areas like the city of Beverly Hills. Bentonite shield gap grouting was deemed to contribute to reduced settlement where it was used. Not all of the contractors chose to use that shield gap grouting. So the tunneling in the gassy conditions also went well. However, there were a few exceedances of the OSHA allowable limit for gas in one reach of the tunnel. In these cases, workers had to evacuate the tunnel until OSHA could give them the all clear to return. That was generally an hour or two. Also, the station workers had to evacuate as well because those are connected. In reach 3 of the section 1 tunnel, we also did something very interesting, which is soil vapor extraction. This had been in planning for many years, but actually came to life here. And the concept is The air is injected in some wells and extracted in others, and it can actually neutralize hydrogen sulphide gas in the ground. In one area, we had 6,500 parts per million of H2S, which is quite hazardous, not explosive, but very dangerous or immediately dangerous to health. Methane levels are 100% in the samples taken. So methane is also reduced by this method. So by activating a vapor extraction system, tunnels could go through this area with no issues. We also monitored basements of buildings in the area to make sure there were no changes in the air conditions in the basements, and there were not. And finally, I'll show you, this is a picture of the system on the surface of Wilshire Boulevard. Here you can see the extraction wells, and because this is 100% methane in some cases, it had to be oxidized, so it's quite a sight to see this on the street on Wilshire Boulevard, but more remarkable was that no complaints or questions from the community, so go figure. There's also a paper by the contractors team on this in the RETC, I think it's 2023, if anybody's more interested in this. And I think this is where I give it back over to Matthew.
We've got the final few slides, because, you know. Do you think I'll pinch it or something? It's nice, it's nice. Anyways, quick about station construction, the same old thing with, you know, all the same stuff that we've been doing for 35 years. But of note here, remember COVID? It was awful, wasn't it? But there was some good things. We had COVID. So this is the Golden Triangle in Beverly Hills. That's where the Kardashians buy all their ugly clothes, and nice clothes, sorry. And we were able to, instead of having to fuss around with traffic and all the businesses, the Ferrari dealership, etc., we're able to get the soldiers in and get the decking and hang the utilities with a complete closure of the street, which really helped us. And I put this picture, the end station at the Veterans Affairs Hospital, which is a really premier institution for the, especially one of the things, probably the world leader in the treatment of PTSD for wounded warriors. It was great because it was in their parking lot and everything we had to do in the street. However, it also had all the mission critical utilities for a hospital, including a steam tunnel, and so we had to hang all of those. And this massive steam tunnel is bomb-proof for security reasons. And then I like this picture. Obviously, we built the tunnels first, and you can see us breaking in, and I guess they look about in the right place, thankfully. The other thing of note is the arched roof, which we mentioned, and I'm mentioning it again, which I said I wouldn't. Oh, well. Here we've got, the excavation of all this black material that the tar impacted or asphalt impacted soil is. Here we've got Yossa Hughes here standing and a couple of boys from the black stuff. This is like, imagine an asphalt batching plant. So we had to excavate through that material. And here's the tar coming in on the water. So we had to deal with all of that, but we did it very well, or our contractors did. It was great. The methane and hydrogen sulphide are dissolved in the water, so we have to, where we've got our station, we have that water going into a drainage layer at the back of the concrete of the station, and then the gases come out of solution. And we use something that's like an inverted roof drainage system. So we have gutters here and upspouts, I guess they are, coming up to the surface. So the methane and hydrogen sulphide safely finds its way to the surface rather than through someone's basement. Oil fields, yeah, with a lot of oil fields. LA was basically built on the back of oil fields. Some of we know roughly where they are, but only approximately. And any abandoned wells have to be abandoned to the latest standards if they're in the way. This is Beverly Hills High School. That's where Monica Lewinsky and Lenny Kravitz went. There were 19 operating wells in the area. This thing is actually part of the operating well. It's actually a drill rig hidden behind this thing. They were abandoning them as we were doing our project. And we did horizontal directional drilling with a magnetometer to locate where the wells were. Three holes and triangulation. You can work it out, can't you? Dave Hindle's figured it out. He's sitting there. We actually found 2 wells, and there we are, abandoning them. And again, COVID was our friend. The high school was not operating at the time, and so we were able to take care of those pretty quickly. We also used the HDD to determine other metallic obstructions like old soldier piles and whatnot. So we're able to find those and cut them off before trying to tunnel through them. Another feature is the spaghetti, whatever, but the reason I've got this slide here is there's our, where the heck are we? Our tunnel. I can't see this, but our tunnels go within 10 foot of a 2.4 metre diameter, 15 bar high pressure water transmission line, and the owner of that water line was pretty concerned about it. So we did permeation grouting was our friend, and we put horizontal econometers right above the tunnel, and we tunneled, there you can see with the HDD, and there's more stuff. And there's a bunch of other important utilities there as well. And we tunneled without it was really nominal ground movements. Another part of the project on section 3, we ended up with this is a soldier piles beneath a building that for the temporary support of excavation, and we had some old as-built drawings that were a bit dodgy, so we needed to get our tunnel as high as possible so we could get the pressure below 4 bar, so we could do successful interventions. I'm sure Donald Lamont can explain all about that if anyone's really interested. What we did is we put some boreholes next to where the piles were, hit the top of the pile, and used a gadget to determine the depth of the concrete. And then we stuck a magnetometer down to find the depth of the soldier pile, and with that we're able to raise the tunnels to within a couple of feet of these soldier piles, and we tunneled beneath them where no one knew, didn't notice them at all, so we got that right. We put this in, bit of whimsy, this thing here, it's actually an old bank vault. This is where we were building the entrance to one of the stations, and when we had a differing site condition, which was we found an old adit that had been backfilled, and it turned out that this was from a robber's tunnel that was built in 1987 to rob 3 bank vaults, and the robbers robbed 2, and then I guess they were thinking maybe come back another day for the 3rd. I don't know. I guess that's those. Yeah, people need to anyway. Future project. We're almost done now, but I know people want to know future projects and that. So I've got 3 that have tunnels. I've got loads of other work, all sorts of stuff, but 3 have tunnels on. So the Sepulveda Pass, the K-Line Northern Extension of Crenshaw project, and the E-Line extension to East Los Angeles. That's an extension of the project Amanda was talking about, the Gold Line. Sepulveda Pass, again, we mentioned the, what do we mention here? Is the west side and the LA basin. There's San Fernando. These are the big mountains here, and this is where the traffic is. It's all stationary most of the day. So there's tunneled options for all sorts of things. Look on the website if you're interested. Well, it's really good, actually, really good information there. But we're doing preliminary engineering and site investigation, and as you can imagine, the site investigation for 5 miles of tunnel through a mountain is like someone's project. The K-Line Northern Extension, that connects the line to Santa Monica with the purple line and the red line, and also Hollywood. Tunnel alignments, because it goes through an urban area, and we're doing the environmental work, the draft environmental document under review. And the last project with Tunnel On is the E-line extension, 2 miles of twin-bore underground guideway and 3 underground stations. That's been environmentally cleared under SEQA, and it's in procurement at the moment. Advancements, what we've done, we actually get our underground construction risk to as low as reasonably practical by using the pressurised tunnelling envelope and the prescriptive implementation of our cut and cover stations. And that means we have nominal ground movements consistently, not just when we need to, consistently. We don't have any really measurable ground movements. And we have no adverse impacts on the outside world, and we like it that way. We have dry and gas-free tunnels. We use the compartmentalisation of the HDPE and the double gasket, the cross gasket with our one-pass lining. And then we've got trying to do a lot of standardisation of the cut and cover stations, etc. Lessons learned, or is it lessons learned? I don't know. Discernment, research. There's obviously a litany of case study technical papers and vanity presentations like this one. We also got a whole bunch of academic studies. We're working with University of Illinois, Lehigh and Long Beach. And they've been studying the pressurised envelope of tunnelling, shoring stiffness, looking at exploratory shaft tar properties. And they're doing this, I sit in these meetings and they do this thing called generative artificial intelligence with the TBM data. But it's all they publish proper academic papers, which is really good. And then we also use some of the things to revise the Metro Rail design criteria and standards. So concluding remarks. So Los Angeles has a world-class rail transit system that will support the 2028 Olympic Games, as well as generally supporting this great city of Los Angeles. The other one is we had these, I mean, Amanda really understates stuff. Incredibly challenging conditions. When I came back to LA 12 years ago, people said, oh, you can't do tunnelling through that. It's impossible, you know. But what we found, if you do all the sound engineering and the homework, you can have successful execution even in these challenging conditions without any mishap. Compartmentalisation of the concrete elements enables future leak repairs. We've really figured out how to design for seismic conditions and gassy conditions. The other thing is, I remember sitting here 30 years ago having to write an essay on necessity is the mother of invention, discuss. And one of the things is we do innovation when we really have to, and then we incorporate the goodies in our future standards. And now for the Oscars. I need to get my, so I'm not like a wedding where you've missed someone out. So you guys need to, don't be shy. Anyone who worked on one of these LA projects, or their firm did, you know, give a wave, and if I miss someone, shout it out, okay? So we've got AECOM, Atkins, WSP, Arup, Jacobs Engineering, Dr. Sar Aldia, Motts, Fugaro, HNTB, London Bridge did a bit. Any other firms work there? Who? In LA? No one? Who?
You got them all.
Did I? Wow. That's it. That's all, folks.
Right, thank you very much. Open the floor, please. Any questions for Matthew or Amanda?
Matthew, you know you said about the gas that goes with the siege. Oh, sorry. Oh. Sorry, Matthew. You know, you were saying about the gasket going through the seat joint for the background.
how did that enable the background?
Well, yeah, I mean, we've got the double gasket, as Amanda said, so we've got so the segments can rock. And what we found is if we had a leak in the back gasket, it would find its way in the network between the two gaskets. And then if you had a defect on the front gasket anywhere in the tunnel, it would leak there. So it was good, but not like perfect. So we put the cross gasket in to compartmentalize sections of tunnel. And the grouting we do is you put like one of these chemical, like rubbery grouts or something in the gap between the two gaskets, so that we can actually get a water tunnel. We used it very successfully on Crenshaw, where John Hurt designed that. We were able to remove the spear bolts, and then you can put a packer in there, and you can put grout in there. You have to pump it in, and grout comes out the top, and you stop, and then you know what I mean, that sort of thing.
Thank you.
Okay.
Donald Lamond, there are a few of us here tonight who have been heavily involved in ITA for a long time. I think it's only fair on behalf of all those of us who are involved in ITA to welcome Amanda as one of our ITA colleagues here, and Ryan, her husband, who are another amateur from the ITA. So welcome to what is possibly part of the home of ITA, going back to Alan Muir Wood's days and Colin Kirkland as past president. So I hope you enjoy your trip to London and to the ICE and to the British Tunnel Society, given you're involved in ITA. Having said that, I think it was a very interesting presentation tonight. The work you've done on gas in TBMs, a number of us involved in the European standard and TBM safety, and we explicitly exclude gas from the work we're doing. It would be very useful to have some sort of standardisation of the experience you've had, both in methane and in H2S. And just to ask a question at the end, you talked about the explosive nature of methane, about the explosive nature of H2S. What about the occupational health issues involved in working in a tunnel where you have tar seeping in, obviously giving off fumes, and people breathing there? How do you overcome that problem?
Do you want to take it, or I can take it, but do you want to take it?
Well, I could just start at saying that the same occupational safety agency, OSHA and Cal-OSHA, they have requirements for and standards for the air quality in the tunnel. For we're measuring oxygen, methane, hydrogen sulphide, and carbon monoxide, so that those are also monitored continuously. Is that maybe?
Yeah, I mean, one of the things is we use the pressurized envelope with the segment, so that and have the screw conveyor at the back, so you get loads of ventilation to dilute it. And then likewise with the station, loads of ventilation. And then for hydrogen sulphide, everyone wears a little hydrogen sulphide button that records the, not just instantaneous, but the cumulative exposure to hydrogen sulphide. Well, we monitor those with gas detection, but again, it's ventilation is just is huge amounts of ventilation. We mandate 100 cubic feet per minute at our tunnel headings. 100,000 cubic feet. 100,000 is like the bathroom, isn't it? 100,000 cubic feet per minute at the heading. So you get your head blown off when that's going. And that's really important, is worker health. And then also for the permanent work, is that's why we were so keen on having the gas-free environment, also tar-free. Because we don't want to have exposure to not only the people who operate the system, but also the travelling public.
Okay, we've got one question online from Tom Emerson. How intense and costly are the instrumentation and monitoring requirements in the downtown areas of LA?
Everything we do is worth every penny that we do. But do you want to just talk about what the instruments we put in, what we do?
For the buildings or for the tunnels, or is he, because?
That's just the question
Talk
that's come
about
through.
the standard suite that we do,
for the monitoring of the tunnels.
Yeah.
So in terms of dollar costs, I'm not sure we could answer that question, but every tunnel, every station has to have gas detectors in rooms that are on the walls against soil.
I think he's talking about geotechnical instruments.
Instrumentation and monitoring.
It's probably geotech, isn't it?
All right, then you.
Okay, so with our tunnels, we have extensometers. We've used the horizontal inclinometers where needed. They're super. Surface monitoring pins, building monitoring points, stations, inclinometers, strain gauges on the pipe struts, building monitoring points, and then we're using satellites with the INSAR system it gives you really good information on generally what's happening with buildings and the road compared with the rest of LA. Because one of the things we do know is that LA moves up and down and sideways just naturally. And so it's a combination of all of them. And we also use liquid levels in buildings. And every instrument that we put in we think about it very carefully. Is that needed? And what information it's giving. And we have a very comprehensive way of managing that information so that it isn't just some boffins looking at it. It's people actually taking interest in it and using it.
Okay.
I got it. Hi. Christoph Eberle, Mont McDonald. Thanks for the fascinating presentation. I was really intrigued to see how LA Metro has adopted emerging new technology over the decades. Now, one element which you haven't touched upon was the move to bicomponent grouting for the primary grout of the TBMs. I was intrigued, is that part of your waterproofing, gasproofing considerations, the type of grout which you're using for the primary grout of your TBMs?
We haven't been considering it. I think that's a great idea, but I don't know that we can rely on that to provide a seal. So I'm sure it contributes, but we haven't done any specific research on that. But it's a good thing to think about.
Okay, thank you very much.
Steve?
Yeah, very interesting paper, thank you. Logistics. The spoil, because of all the contamination, whatever, you haven't mentioned about the muck away. Did that go by train, by road? Did you conveyor it out? And did you separate it? So the more normal soil went to one tip or whatever. What about all the tar that you tunneled through? Where did that grow? How did you treat it? Covered trucks? What? And then you mentioned the tar pit and pumping the water. Presumably you had to treat that first before you disposed of it? Or you've got volumes of water. How did you deal with that?
Yeah, I can't see who's actually speaking. Can you raise your, okay, it's dark out there. Yeah, no, that's a really good question because during design, we were quite concerned about disposal of that material and handling and where are we going to take it. And but as it turned out, the material met the requirements for disposing in the local landfills and using for cover. So,
Wow,
at first we thought we were going to have to ship it to, out of the state to special disposal sites, but in the end it was not considered hazardous or contaminated.
Yeah, I mean, talking about the kit they used, I mean, if you're talking about the asphalt infused sand, I mean, they used conveyor system in the tunnel and also vertical conveyors to pull the material to the surface. And I mean, there was a lot of, it's pretty tricky doing that, but they had some people who knew what they were doing,
And the water? Contaminated water, did you have to treat it before disposal?
The water from dewatering typically had hydrogen sulphide that was treated in a plant at the site. So we didn't have too many issues with that either.
Okay.
Yeah, I mean, you have to. I mean, it's an urban area, so you're having to treat the water anyway because there's all sorts of stuff in there that people have just chucked in the ground in the past. So you have your treatment plan there, you change the filters when you need to and that. So it wasn't really a particular issue.
There are some things, though, that, and we did put this in our specs to note, that this tar material does tend to dry on things and harden, and it's very difficult to clean the equipment, and so there are all kinds of things you have to learn to do to work with it. But.
Yeah, thank you.
Janie?
Hi, Shani Wallace from Tunnel Talk. Thanks very much, Amanda and Matthew. A great rundown on what is going on in Los Angeles. 2 questions, if I may. You spoke about the wonderful crossover cavern on the regional connector, but you still seem to be very heavily committed to cut and cover stations. Are you reconsidering that approach and coming up with mined station options? And the second question, if I may, the high-speed rail in California is going to have to come through the same mountains into Union Station. Are you sharing all the lessons learned and the techniques and data that you have with the high-speed rail folks? Thanks.
Yeah, on the first question, I mean, one of the things when I came to LA 25 years ago, there was really great folks in tunneling there, but there was a lot of criticism, and I think what the profession and the owners, or clients as you call them here, they wanted to do stuff that was tried and tested and they wouldn't foul up. And also, you need to be using what the local constructors are actually experienced in using. So that's why we got the cut and cover stations and the bored tunnels. And we didn't want to, I remember K.N. Murphy, he said, don't foul it up. Because he used to get very concerned if I was like, oh, why don't you do this? Why don't you do that? And we did the cavern. We were in very good ground conditions, and we all know good ground makes good tunnelers. We are actually looking at a study at the moment for the single bore, the mine station and whatnot as an agency, and it's something we will consider. But again, we don't just do innovation for fun. There has to be a meaningful benefit. Regarding collaboration with other agencies, absolutely. I mean, the big people we took Seattle. Anthony Pooley, as some of you know, used to work in his English. He's up in there. I talked to him quite a bit. But we've had meetings with the high-speed rail folks, and also the consultants all work on all these projects, and also Caltrans. I was talking to a gentleman here from Highways Agency and get something going, chatting to him, because it's very important that, as you say, Shani, is that owners talk to other owners and share their experiences and don't work in a silo. Because it's quite easy to do that because you're shy about, I don't know about this subject, can you tell me? But it's a good conversation to have.
Another one online from Bill Gross. Can you give an idea of the cost per metre or kilometre for tunnelling in Los Angeles? I'm just thinking that I don't see the nexus to costs from our presentation today. We talked about a lot of stuff. I intentionally avoided talking about costs, not because we're ashamed of it, but I mean, we still do. I can't give you an off-the-figure number on that. Okay. It's not. I mean, I'm just not being evasive, but I haven't got one off the top of my head, and it wasn't really what our paper's about. About costs, but it is a good subject, and yeah. Sorry, Bill. But good question, because you good question there. Another question from the floor.
Yeah, Martin Knight, LBA. I liked your answer about the money you spent on all the instrumentation. It was worth it. And just associated with that is the investment in time spent with stakeholders, reassuring them about, say, tunneling is a good idea, it's safe. How much time do you spend doing that? Because you can publish papers by academics giving all the technical reasons why you can do that, but at the end of the day, you're going through neighbourhoods. So what kind of work are you doing around stakeholder management?
I'll start it off. One of the things is we're us engineers, we're really good at all the technical stuff. We just make it look easy, don't we? But spending 6 years as project manager, probably 5% of my time was anything to do with technical stuff. Most of it was dealing with people, other organisations, third parties, and everything. And that's the most important thing. And you do it at various stages. Amanda, just last week, just say what you were doing last week.
Well, I went to a community outreach meeting. A lot of this work is done during the environmental phases where we present alternative alignments and explain to the community, especially when a tunnel is near their house or under their house, and there are a lot of questions. We couldn't really see from the purple line alignment, but it actually goes what we call cross-country from Century City area to UCLA, and there are 200 parcels that are affected by that. They're not, tunnels not directly underneath houses and all of those, but easements have to be obtained. So there's a lot of time expended in community meetings saying there won't be noise issues, or the tunnel boring machine operates safely. We're going to monitor for settlement when the trains are running. I mean, this is very similar questions in all of these public meetings. Oh, but my building is historic, and so therefore it's different. So you have to explain the process that we go through to evaluate buildings such that property owners can understand it. And sometimes we're successful, and sometimes they don't believe us. So it's a really important thing, and Metro spends a lot of time with community outreach and going back, answering all the questions. Some people are never convinced, but most of the time it's successful.
I'm just saying on Section 3 of the program, the work done by folks like Amanda, having someone who actually is the real deal, answering questions directly to the public. I mean, we've everyone on Section 3. We've had no one like being against the project. It's shocking. And you kind of think, well, what do these construction relations and public, but what do they do? I tell you what, it's what you don't see is what they do.
Yeah, and
having the professional person, some who's just talking, just direct, and it's credible rather than some just talking head,
And one thing that we have to convince people, it's not just the tunneling itself, but it's also the train operations. We like to have a straight alignment. It's best for everyone because we can travel faster, you won't hear as much noise. But that process sometimes takes a lot of convincing. So I don't know if you've had this similar experience.
Oh, yeah, we do, yeah.
All right. Dave?
Hi, Dave. Being a Hollywood disaster movie fan, I was just wondering, how do you manage earthquake seismic risk during construction? Bearing in mind, every year that passes without a major event, your ODE and MDE is increasing. It's not just 4%, it's increasing year on year. How do you actually manage it during the construction phase before the permanent works are in and the design earthquake criteria are met? Do you have a criteria for temporary works?
We do. I don't want to quote it because I think it's considered that construction is an extremely short duration, relatively speaking. So there is some increase in loading for seismic considerations, but it's not the same as for the permanent structure.
Do you put limitations on the time between?
Yeah, it's note 6 and 7 on the second drawing of the Metro Rail standard plans for shoring. And for the life of me, can't remember what it says. But Dave, I'll send you a copy. No, I mean, how many hours and hours have people spent talking about this? And and some of it's there is a time element, and a lot of it's based on there's a lot of particularly it's the shoring that's the big thing. There's a lot of experience with shoring, going through some seismic events, and it's not fallen down. And also thought and good engineering and stuff. But there's actually some notes on our standard plans.
Thanks.
Yeah, okay.
Hi, Dr. Sauer and partner, Sebastian Kumpfmüller. You mentioned that you have to do exploratory drilling every 100 meters along the alignments according to the code. I was wondering if you are able to challenge this requirement and rationalize it by that you're dealing with an urban area. You must have a lot of third parties left and right, and are you able to use data from their basements, from their building sites and so on? It's just a question because we are able to do that here in the London urban area and can rationalize the probing and exploration. I was wondering if that works as well in LA.
Yeah, maybe I didn't explain that correctly. I was really stating that our boring spacing was about 100 meters, but that is based on the judgment of many geotechnical engineers, and we do collect data from all the existing buildings that we can, both in our files, go to the building department. Most of the time, buildings aren't as deep as the tunnel, so you can't, it's not always useful, but any data is useful. So no, that spacing is not a code, it was a judgment for some of this area that we were going through. And again, that tunnel advisory panel that I mentioned were also involved and use their sage wisdom on how many borings is enough. You know, that we always have to ask that question.
One of the things that I believe is very important to have standards and stuff, but I do believe that the engineer and engineering calcs and skill and experience and judgment should be driving where you put each borehole.
Mm-hmm.
Another question online. This is from Louis Peak. What proactive measures are Metro taking to reduce project risk and or costs due to third-party interface issues? For example, interface with railroad crossings to avoid the contractor pricing in risk.
Okay. Example, we've got a project that goes underneath the Union Pacific Railroad, and one of the things the project is doing before we actually issue the bridging documents is we have extensive engineering meetings with say, a railroad. And it's the same, that actually a good example with that big water pipe. We had meetings, I don't know, Roy Cook, I don't know if some of you know him. He must have had meetings about 10 years ago with these guys. And then, so what we do is we find out what the requirements are for that third party. And we make sure we really know what they are, and we put them explicitly in the bridging documents. And what we found actually is when we actually had the contractor actually then going to get the permits or whatever from them, it was relatively, nothing's easy, but we'd done the homework and there's no surprises, and everything, it works well, and it's so important to do that. Don't just, oh, it's too difficult to do, just stick a note on the bridging documents, liaise with, just name the third party that won't talk to you.
Any more questions from? Yeah.
Hi. Sorry. Amanda Matt, sorry. John Nicholas, National Highways. Thank you both very much for a really good, informative presentation. You mentioned some of the engagement and collaboration that you had with the community. Were there any standout contributions from any of the community engagement exercises that you undertook, either with community members, residents, or particularly with people from the emergency services that may have to respond to either incidents or events during construction or during the operational phase of the assets that you were delivering?
I can't say I could remember anything in particular, but I am always impressed that we learn a lot from the community, because those people live there. They understand what's occurring, you know, what time of day things are happening, and so without a specific example, I can say that we do take back a lot of information that we learn from the communities.
Yeah, I think one of the things is because Metro is a mature organisation, we have long-standing agreements with every utility. We have master cooperative agreements with most of these organisations, and I'm just thinking, is anything particularly outstanding? Working with Caltrans, the State Highway Agency, a lot of people see them as we have great working relationships with them, and it's being open about things up front, actually addressing the real technical issues rather than just seeing this as being a bureaucratic hurdle. It's really important. And is there anything? I mean, who's really? Everyone's. I mean, people actually genuinely want to help us. It might not seem like that at the time, but all of these agencies, they're wanting a public transit system built, so that they help us. I'm trying to think who's been really nice. I mean, it'd be like saying, "Oh, they're nice; the others aren't nice," you know.
Yeah, I don't know. But I think the question is more about what are we learning from the community as a and
what do we?
Like I said, we do, but I just escapes me what.
I mean, yeah, trying to think. I don't want to single out someone because I'm thinking of a couple that have been really, really helpful. But I mean, if I say that, I mean the other, well, about me. There's probably someone who wasn't very helpful. And I'm not saying who they are.
Right, I'll take one more online and then one more for the floor if anyone's got any. So this is from Neo K. Nuno. Given the potential higher upfront costs of sustainable methods, how did you balance those costs with the long-term environmental and financial benefits, such as reduced maintenance and energy consumption over the life cycle of the project?
One of the things is that is an incredibly complex issue of which I don't know how I could give it justice in the 1 minute that people are going to tolerate me talking in this room. And I would love to come back in a couple of years' time and talk about that, because we are doing some really cool stuff related to sustainability. We actually have a chief sustainability officer at Metro, and maybe he could come along here and talk about some of the cool, and it's not just really actually tangible things that we're doing here at LA Metro.
Yeah. All right, one more from the floor.
Yeah, thanks. Just going back on evacuation, fire strategy, if you could elaborate what sort of time you allowed for consideration between this length of tunnels that you have, evacuation procedure, fire rating, in terms of what it takes to get the passengers off the train to a position of safety?
Well, in the tunnels, the position of safety is considered the adjacent tunnel in a fire. So passengers have to get off the train and walk to the nearest cross passage, which is 800 feet, which is how many meters?
A third of that.
Yeah. Thank you. I've had
multiply by 0.3048. I see Bob Eibel's done it in his head. How much is it, Bob?
I think it's an international standard for pretty much for cross passages. So there's not much time needed for the passengers to get to that point of safety. Does that answer the question?
Yes,
yeah.
I mean,
And
that's fine. As long
then
as
a rescue train is sent to pick them up if needed.
Yeah, fine. If you follow the standard, not an issue.
Yeah.
Just following on, just an overall question, and it's very difficult from start to finish. Was that the program that you envisaged? You were able to say, okay, I can actually build this length of tunnel within this short time frame that you set, the original objective, and what was actual compared to your original objective?
Do you want to
I don't understand the question.
Well, I guess, one of the things that, we were just talking about it over lunch today, was that this project wasn't a twinkling in anyone's eye. Say the Purple Line. This is a massive endeavour, It was less than 20 years ago. Oh, sorry, it would be less than 20 years from it being a twinkle in someone's eye to people riding on the trains. And people say that's a long time. But America's a democracy, like Britain, and I like it that way. And we have to do consultation, we have to work with third parties, we have to work with property owners, all these people, and we have to follow the law, the processes that take time so that people's rights are protected and done in a proper way. If people aren't happy, they can have legal, all this stuff. And then we need to actually maybe do some good engineering so we don't just suck it and see when we're doing our tunnelling. The other thing is, I'd rather our tunnels were built without nothing going wrong. Maybe it takes a bit longer. That's more important than rushing it. So, how long? We will have the Purple Line will be completed in 2027, and the punters will be using it well before the Olympics. That will happen. When the project was first envisaged, we didn't have funding we only had funding for the Section 1. And the Section 3, I don't know, did you think Section 3 would be built anytime soon when we first started Purple Line?
It happened pretty quickly.
But it happened, I mean, it happened, we got the money, and we took care of it. And so I think less than 20 years is pretty good, but could it be better? I'd love to hear from someone some ideas to speed it up. But I'd like being in America, I like being in England, where we have due process that does lengthen the project's time, because it's nicer that way.
Thank you.
Okay, the level of questioning shows how much interest your talk has generated. So final show of appreciation for coming across here and talking to us. All right, so just wrapping up with a few announcements. And before I do that, can you make sure you've all signed the attendance register, please? Has it? Where is it? Yeah. Okay, get what? Next one, please. So the book is, after 6 years in the making, 50 years celebrating British tunnelling. The first editions will be here in first week in October. I think it's about 20 copies coming. Mike's taking a couple to New Zealand with him to present at one of their evening meetings. The books will be available at the conference as well, which Daniel's going to talk about at the end. And then the bulk delivery, for those of you that all pre-ordered, will be arriving the back end of October, early November. So thank you all who ordered that, but we are still taking orders. You can get your pre-orders at this list price, but once the book arrives, there'll be an increase. So if you haven't ordered the book and you're thinking about it, please order it now. Okay, next one. So yeah, drinks sponsored by Normet and Herring Connect tonight, and WSP on the food. I almost missed the food there. Right. Next one, please. All right. Next one, please. Yeah. All right. It wasn't in front of me. So, yeah, evening meeting, Wednesday the 20th of November, joint BTS Concrete Society meeting, the Koi Glass Hydro Pumped Storage Scheme. Okay, next one.
Which is the one at the conference, at the end of the conference.
All right.
So essentially it'll be about 3 projects. So they're shortlisted by the ITA for the 50th anniversary, so 3 monumental projects.
That's right, yeah.
Channel Tunnel, Tideway and Crossrail. We'll have a person presenting about one of them for 15 minutes, give an overview, but it's also the day where you can access the conference and the conference exhibition for free. There'll be registration required for it, but it's a free ticket to the exhibition. And then later on, we've got the lecture, which is going to take an hour, and then there'll be some drinks and refreshments afterwards. And free drinks, so more on that later. 3 iconic projects, yeah. Excellent. So we've done the Concrete Society. Next one, please. So the Health and Safety course, which is on the 18th and 19th of November, is held here. And we're taking bookings. We've already had over 20 people. So excellent course over 2 days. Encourage you to put your people on it. Okay, next one. So the Young Members Conference, this date was rearranged, so 29th of November on a Friday, and there's call for registration if you see the BTS website. All right, so that's coming up end of November. The Net Zero Tunnelling Group, so this is a new initiative that's come about, so looking to come up with some direction and guidance to the industry on net zero in tunnelling. And the group has members representing clients, consultants, contractors and suppliers. The purpose is to accelerate progress towards net zero carbon tunnels by sharing knowledge and ideas and shaping best practice. So the group is a subsidiary of the British Tunnelling Society. Governing documents have been prepared and the website to follow. Okay, Daniel, conference.
Yep, thank you. So just quickly before I move on with that, just with regards to the slide that everyone missed, so the next BTS meeting, which is on the evening of the 8th, as Divik said, what you do need to do to enter the QE2 building is you have to register, ideally pre-register as a free visitor to the event, to the exhibition, because if you don't, you'll get caught in a queue. So obviously I appreciate everyone will be trying to get there, they want to get up to the presentations, and then obviously to the drinks reception after. So we strongly advise you to make sure that you pre-register for the event, so it's the free pass for the exhibition, okay? If you're not able to come as a delegate or able to come obviously during the day and you're going to be there anyway. So my name's Daniel, I'm with Tunnelling Journal. We're part of the team, we work together with the BTS, we organise the conference and exhibition. Just a quick overview of this, so we're expecting 800 plus attendees to the event across the exhibition and also the conference, 55 or 50 plus exhibitors. Actually, it's nearer to 30 plus speakers at the event if you include the individuals that are involved in the panel discussions as well. So just looking here at some of the speakers that are part of the event, this is literally just a snapshot. It's just a few of the people that are going to be there. We've got a good mix across the 2 days, across the panels, male, female, and so on. So we're covering everything across the event. Great presentations. In fact, it's one of the best lineups we believe that we've had in recent years to the event. So as I said, 30 plus speakers. It's single track. If you include the panel discussions as well, we have those across the 2 days. We're covering innovation, sustainability, technology, including AI. Projects that will be spoken about will include overseas UK projects, so HS2, Lower Thames, Tideway, Grand Paris. We've got projects in Stockholm, Gothenburg and Hong Kong as well. With regards to this, the conference that we organise, a huge amount of time goes into that from Tris Thomas, also Dan Garbett, who's the conference chair, and then other members of the BTS who also help to put together the programme, spend a lot of time inviting people, go through the stresses of trying to put the programme together. People are then sometimes not available to come, so then you have to fill the slots again. So there's an awful lot involved that people may not necessarily realise or appreciate across that. So now moving on to our exhibitors. Again, this is just a handful of the exhibitors that are part of this year's event. 50 plus companies, many of those companies return year on year. We've got 14 new companies this year. We've got many companies from the UK and overseas. These organisations, they make a huge investment on their stand, on personnel to be there. They want to meet you. They want you to come to the exhibition. If you can't attend the conference, come to the exhibition, meet them, come for a day, come for a few hours. just try and be part of the event as best you possibly can. We're also this year, we're working with association pavilions. We have an association pavilion. We're working with various associations. The reason we did that is because we believe that it's going to spread the reach. They're connecting with their members in the same way that the BTS does. So hopefully that will look to generate new people that are going to attend this year's exhibition and conference as well. So you've got choices. Sign up, be a delegate, come to the conference, come to the 2 days. If you're part of that, it's great value, 225 for BTS members, non-members 275. You've got access to the exhibition. Obviously, you have access to the lunch, the coffee breaks and so on. So you've got great opportunities to come along to that and to network. Or, as I said, visit the exhibition. It's free. There's no charge. Obviously, we appreciate people are really busy. You've got to take the time out. Just as a note, and I'm not sure, how many BTS members have we got now?
Around 800.
Okay, so already signed up as delegates, BTS members, we've got less than 10%. Okay, so not a huge amount. So what we'd like to do is obviously try and encourage everyone that's here, obviously to work with the other BTS members and non-BTS members and people throughout the industry to encourage people to come. It feels almost like we put on this event. As I said, huge amount of work goes into it, and perhaps people are thinking, well, someone else is going, I don't need to go. But it's a great opportunity for older engineers, for younger engineers, to encourage people to come. We're also working with universities. We're trying to encourage students to come along to the event. And after this event, come and have a chat with myself, come and talk to Tris. If we're doing something wrong, and it shouldn't be 2 days, or it shouldn't be a conference, or we've got the wrong presentations, just come and talk to us. Give us your feedback, positive, negative. Just let us know what you think and what we can do to make it the best possible event moving forward. So on here, we've got scan the QR code. You can go on there, access that, register for the events. We've also got social media. We've got a huge amount of social media activity at the moment. I look at it every day. I can see through LinkedIn how many people have looked at it. It would be great if more people clicked like, reposted, shared it. We collectively here can reach so many more people in the tunneling industry to encourage them to come to this event. We work with the BTS. It is a BTS event. I think people forget that. It's not just commercially from a tunneling journal point of view. It is an event for this industry, for the UK. So we encourage everyone to help us as best you possibly can. I'm not lecturing you. I'm just trying to take this opportunity to kind of, emphasise what we're trying to do with the event. So I appreciate your time. Enjoy your drinks. Thank you.
Okay, final slide is about the book again. So just a reminder, you can still pre-order. QR code there, British Tunneling Society website. The book will be coming early October for the initial set of books, and then the main bulk back end of October. Okay, see you all in the bar. Thank you very much.